I don't know why it's not counting down, but I think we're recording. Okay, so today, along with the unit circle, is probably the second most important day of the entire year. Okay, not hard, right? But super, super important. It never stops. Okay, Audrey, go to that one, please, because I need them to be paying attention. So if you don't want to pay attention, that's fine. I need them to be paying attention. Just go over there. It's fine. So, So what we have to do, we're going to deal with the Pythagorean identities. Okay, the Pythagorean, because they're based on the sides of a right triangle. So what I've scripted out here is that's a unit circle. Okay, so I have any point on that circle has a coordinate pair of cosine of an angle, sine of an angle. So let's go ahead and draw a line to it. So now let's see if I can draw a line using this thing. Is it in white? There we go. There's a line. And then see if I can do it again. I'm not sure. Whoops. Okay, I'm trying to be too precise now. I'm trying to move it over. Okay, if you can work with me and just say that's joined. That's joined and it met at the circle. Sorry about that. So there we are. We have our circle. We don't our triangle. We don't use them. Imagine we looked at them. We looked at them for a long time when we built the unit circle. So we know that this side length right here has a side length of sine, and we know this length right here has a side length of cosine, and we know this length right here is the radius of the unit circle. It's 1. So there's my y, there's my x, and there's my radius. There's my y, there's my x, and there's my radius. All right, so Pythagoras says leg squared plus leg squared is hypotenuse squared. So what we're saying is if I square the horizontal leg, if I square this leg, that's saying, let's push this over here just a little bit, that's saying cosine squared plus the other leg, so that's the vertical leg, cosine squared plus sine squared is equal to hypotenuse squared. Hypotenuse squared, 1 times 1 is 1. So right now we have the basic Pythagorean identity, and didn't say it was hard. Super important. Super important. Okay, so that's your first big identity right there. Cosine squared plus sine squared is 1. From that, many can spin off, but there are 2 very common ones. So let's take the so I'm going to move this up so we're not distracted with what's going on there. So let's take the ratio that we just proved, cosine squared of an angle plus sine squared of that same angle is equal to 1. Let's do a legal operation in math. What thou doeth to one term, thou doeth to all. So we're going to divide them all by cosine squared. And when I use my identities that I know, I divide cosine squared by cosine squared, leaves me with 1. I divide sine squared by cosine squared, that is tangent squared. And when I divide 1 by cosine squared, that is secant squared. So now I have my second very popular identity. And those are on your sheet, and we'll pull that sheet out here in a minute. And then let's do the same thing again, but we'll do it with, I'm going to go one step larger. Let's do it with dividing by sine squared. So there's the basic one that we proved originally. Leg squared plus leg squared is hypotenuse squared. We proved that. Then last time we divided by cosine, let's divide by sine squared this time. So if we do it to all of the terms, then it's totally legal. Cosine squared divided by sine squared is cotangent squared. Sine squared divided by itself is 1. And 1 divided by sine squared is cosecant squared. So there's the last common one. But from there on out, so I've got, let's see, I've got 1 cosine squared plus sine squared is 1. We've also got many others that can come from that, and we just have to manipulate it. We don't have, my suggestion to you is you only memorize 1. You understand the right triangle, and you commit this to memory. Everything else will develop muscle memory as you use it, and it will also be, you'll able to manipulate it. You'll have plenty of time to do it on a test. So from here, I could say that cosine squared is equal to 1 minus sine squared. And I could just keep going on all day long, right? I could say sine squared is equal to 1 minus cosine squared. And I could say, what could I say? I could say cosine squared plus sine squared minus 1 is 0. You just keep on going. So, but you're going to have to do that, and we don't have enough time to give you all the permutations, but you all know how to add and subtract from one side to the other. So that's the basic Pythagorean identity. And then we're going to, how we use it. So let's do some examples. So we're going to start off. So let's do an example of solving in a different format, in a different way. So if I told you to solve for cosine of x, if sine of x is equal to 3/4 and x is less than or greater than x is greater than pi over 2 but less than pi. So why don't I explain the instructions kind of afterwards first? Well, at least this component of it. You'll see it very easily once we actually do the problem. So let's just go and use our identity to solve for cosine. So I know sine of x is 3/4. So that must mean, is there any way is there any formula, and that's what you ask yourself, is there any formula that's got cosine and sine in it that can help me? Well, yes, we just learned that. So we just said that cosine squared no. It's going to be no. So we know cosine squared plus sine squared is equal to 1. So we know what sine of x is. We know sine is 3/4. So let's rewrite that. So let's say cosine squared of x plus my sine value squared. So cosine of x plus 3/4 squared is equal to 1. Now just solve it, really, because what do I have? I only have one thing to solve for. It's just a basic algebra 2 solution now. So let's just clean it up and make it easy. So let's see, cosine squared of x plus 9/16, because that is 3/4 squared, is equal to 1. I'm obviously doing a ridiculous amount of steps here. If you can do it in your head, that's exactly what you would do. So then cosine squared of x is equal to 1 minus 9/16, right? So that's the same thing as saying 16/16 minus 9/16. So cosine squared of x is equal to 7/16. But I asked you to solve for cosine, not for cosine squared. So cosine of x is equal to plus or minus the square root of 7 over, square root of 7 over the square root of 16. All right. So now is time to bring back that original black box that I said we'll decide at the end. So we were told that sine is 3/4, sine of the angle x is 3/4, and x is less than pi, but greater than pi over 2. So whether you write it or not, I would like you to think that you're in quadrant 2. Because here is pi over 2, here is pi, it's bigger than pi over 2, yet it's less than pi. So you're somewhere in that quadrant. So now, let's go and evaluate, let's go down and look. So I'm told, I figured it out with all of my, I'm getting good at this algebra stuff, so I know that cosine of x is plus or minus the square root of 7/4. And I know that x lies between pi over 2 and pi. So what is the answer? Positive square root 4, square root 7 over 4, or negative? Negative, and that's it. Your answer, you're done. So cosine of x is equal to your negative square root 7 over 4, and you are done.
Could you write it also as like the answer, instead of being square root of 7 over 4, could you just do negative, like a big square root and then 7 over 16? Or would you rather have us write it?
Right, because square root of 16 is a nice simplified number. Yes, if you can simplify it, do it.
Okay.
Yeah, good question. All right. The other example, and then I'll let you break free. Do some examples. Is we're going to use an identity to factor. So if I gave you cosecant squared of x plus cotangent of x minus 3 and told you to factor. The common thing I will hear is someone will say to me, what multiplies to -3 that adds to 1? And you can see why they're saying that, right? Because your squared term has a coefficient of 1, your constant term has a -3, and everyone's used to multiplying that, and they're used to seeing what adds to and multiplies to respectively. But the problem you have here is they are different trig functions. That's like saying, x squared plus y minus 3. You can't factor that. So what you have to do in this situation is make a replacement. And you make a replacement with something that is equal, which is known as identity, right? So, I have my back to you. So, you've only got options. You can only replace cosecant squared, cotangent, or -3. And experience is going to dictate it'll be easy. -3 doesn't really change, or there's no purpose at this moment. Sometimes I could write it as 1 minus 4, but anyway, that's another story for a bit later. But your squared trig function has a replacement that is useful. Squared trig functions have replacements that are useful. Squared trig functions have replacements that are useful. Not power ones. Those are just sine over cosine or cosine, or whatever it happens to be. This this cosecant squared. Well, we know that 1 plus cotangent squared is equal to cosecant squared, right? From our, here it is right here. From our identity manipulation, we took our basic Pythagorean. We said leg squared plus leg squared is 1. We took that. We know that to be absolute truth, and we used correct algebraic manipulation. We divided every term by sine squared, and we resulted with cotangent squared plus 1 is cosecant squared. They're exactly the same thing. They're just dressed up different. They got different costumes on, different clothes on. So but they are exactly the same. They would look exactly the same graph in your calculator, right? One's just going to a Halloween party and one's going out to dinner, right? So let's make a replacement. So we've got cosecant squared, which we know is 1 plus cotangent squared plus cotangent of x. I'm being lazy with my language. Now look what you have. You have only a single trig function in the expression. Now it becomes easy. Let's just group them all together and see what happens. So I've got a cotangent squared. I like to write my squared term first. I've got a single positive cotangent of x, and I have -3 and +1, which is -2. You guys are right back then? Question? No? Sure. Okay, so I'm just doing my little yellow box thinking right over here. So if this were algebra class, it's no big deal, right? We just say, all right, so I've got, an x squared plus an x minus a 2. I have a base squared, I have a base, and I have my -2. And you and I can all factor that. We say, oh, what multiplies to -2 and adds to 1? We say that's x. Oh, that's going to be +2 minus 1. All right, x squared minus 1x plus 2x. That's good. Now it's the same thing, but this time we're going to be cotangent of x plus 2 times cotangent of x minus 1. And later on when we solve, we'll set it equal to something. But for today, that's it. All right. That would be it for the lesson. So I'm going to give you 2 examples to start off, and then I may actually, you're probably going to need a couple. I'll probably get you one more. I did not expect that to go so quickly. I'll give you another one. So let's do, I want give you cosine of x is equal to 4/9. X is less than or equal to 2 pi. However, it is greater than 3 pi over 2. Solve. Actually, not solve for. Evaluate cosine of x. Sine of x, sorry. That'd be your first one. Second one would be sine of x minus 2 cosine squared x plus 1. And I'm going to have you factor that. And the people on the video, that's all they'll do. I'll find another one for you guys, and I'll make sure you get some help. We'll go through it together, okay? So I'll leave those right there. I'll stop the video.